Okay, in section 7.3, we're going to focus only on the double angle formula, and that's all you're going to be tested on your final exam. So the double angle formulas, there's three basic formulas that we're going to be looking at. So if we're given sine x equals some ratio, like 3/7, and we know which angle or which quadrant the angle is in, we can use some formulas to find sine of 2x, cosine of 2x, and tangent 2x. X is the angle, and then when we double the angle, that's going to be 2x. Sine of 2x is not the same as 2 times sine x. And the reason for that is on sine of 2x, we're doubling the angle. If you multiply 2 times sine x, you're doubling the ratio. It means two different things. You're not doubling the angle, you're doubling the ratio. So those are not equal. Double angle formula for sine is one that you have to memorize. Sine of 2x equals 2 sine x cosine x. There's a couple different ones for cosine x. You don't have to memorize them all. There's times when one may be more advantageous to use than another, but basically if you know one, you're good to go. Cosine of 2x equals cosine squared minus sine squared. This is the one that I usually remember myself off the top of my head. The other ones you can derive by using Pythagorean's theorem, and that was sine squared theta plus cosine squared theta equals 1. And then, solving, for example, for cosine squared theta in this one, I'm going to get 1 minus sine squared theta. If I substitute in 1 minus sine squared theta in for cosine squared theta, I'm going to get 1 minus sine squared theta. That's just taking out cosine squared and putting in 1 minus sine squared, and then another minus sine squared theta. So if I combine those like terms of minus sine squared and a minus sine squared, I get 1 minus 2 sine squared theta. So it's really, if you know one formula, you can derive the other ones by using Pythagorean's theorem here of sine squared plus cosine squared equals 1. So it's up to you. The third one is the tangent of the double angle, and that's 2 tangent x over 1 minus tan squared x. So the way these problems work out, and you'll want to write this one down, if you're given one of the trig functions ratios, for example, cosine x equals 3/5, and you also have to be told where the angle is. So in this case, it's in quadrant 1. We're going to find sine 2x, cosine 2x, and tangent 2x. So the first thing I want to do is draw up the situation that I have here. So I'm in quadrant 1, which is up here. Remember, when you draw your right triangle, you start from the origin out and drop the right angle back down to the x-axis. The angle theta is in here, and then the opposite is over here, adjacent, and then hypotenuse. So cosine x, or cosine theta in this case, is going to be the adjacent side over the hypotenuse. To figure out the opposite side, we're going to use Pythagorean's theorem of 3 squared plus whatever the opposite side is, we'll call it y squared, equals 5 squared. And then solve for y. So I get y squared equals 16. Y equals plus or minus 4, but because the y is up in quadrant 1, it's positive 4. All right, so once you get your triangle set up, then we go to the formulas. Sine 2x equals 2 sine x cosine x. And what I would do is write the formula down every single time. So now what I'm going to do is do 2, the fraction for sine x, or sine theta. I'm just going to call this x in here because they're using that as their angle measurement. So 2 sine x. Sine is opposite over hypotenuse, 4/5. and cosine is adjacent over hypotenuse. So all I'm doing is putting in the ratios for those trig functions. All right, and then go ahead, multiply straight across. So I have 2 times 4 times 3, and then 1 times 5 times 5. And so that's the double angle formula. Okay. So for cosine of 2x, you're going to have the formula, and you're going to have to excuse my dog. She's found her new toy, and she's now squeaking it. So we'll keep moving on. Cosine of 2x, you can use any one of these 3 formulas. I'm going to use the cosine squared x minus sine squared x. All right, and then I go back to my triangle. Cosine was adjacent over hypotenuse, 3/5, but you're going to have to square it. And sine squared was opposite over hypotenuse, and then square it. All right, so squaring those, I have 9/25 minus 16/25. And again, if you're not great with your fractions or, whatever, use your calculator to help you out. This is going to come up -7/25. Okay, and again, you can always use your calculator if you need to. And then tangent 2x. So again, all I'm doing is going back to the generic formula up here, 2 tan x over 1 minus tan squared x. And then going back to my triangle, so you can see how important the triangle is on this, and figure out what the tangent function is. Tangent is opposite over adjacent, so 4/3. So I have 2 times 4/3 divided by 1 minus 4/3 squared. All right, so again, just multiply straight across 8/3 over 1 minus 16 over 9. And again, pull out the calculator if you need to. Let's figure out what our denominator is going to be here. So I've got 1 minus 16/9. Hit enter and then do math, enter to get -7/9. So I'm going to take 8/3 and divide it by, and that was, again, -7/9. So I can do the keep, change, flip. So change division to multiplication, flip, and then either cancel, or I can go ahead and just multiply using the calculator, and then again reduce it using the calculator. So I have 8 divided by 3 times 9 divided by -7. Convert that over, math, enter, and I get -24/7. And that's the ratio for tangent 2x. So these are all of my answers. Now here's the kind of cool thing, like if math is cool, here's the cool thing. Tangent 2x, excuse me, is sine 2x divided by cosine 2x. So I could have saved myself a little bit of hassle here and just taken sine 2x, which was 24/25, and divide it by -7/25. Do my keep, change, flip, and I'm also going to get 24 over -7, or -24/7. So if you're confident that you got sine 2x correct and cosine 2x correct, you could use those two fractions divide them, do your keep, change, flip, and you're still going to get the same thing as if you plugged into this formula here.